Hi ladies, in this video we're going to go through 8A, which is review of probability. Even though it's a consolidating section where, you're probably familiar with some of these terms, it's a good idea to go through it again. Probability often scares students, I should say scares, but they find it difficult because often it's wordy, but once you get your head around the context of the problem and what the words are, it's not as difficult as you might think. So for me personally, probability is a topic that I've always thought, oh my gosh, it's so confusing, but every time I do it, it's fine. So if you do find it confusing, just remember, it just probably seems a little bit more confusing than what it actually is. Because just working through as many problems as you can, 8A is relatively simple, but when you get into the more complicated stuff, you just got to be familiar with what the question is actually asking you, because there's a few ways you can do probability. Okay, let's get started. So these key ideas you need to have in your bound reference. Now, I don't mind if you handwrite them or you print them and paste them in, but they need to be in your bound reference. Okay, so for every topic, I will create this for you. If you wanted to work ahead, you can easily take a screenshot yourself or write them out. The thing is, some of them have diagrams which can make it a bit longer, but please try to get into the habit of always putting stuff into your bound reference. So not only the key ideas, but difficult questions should be going into your bound reference, as well as a few examples. So as we go through this video, maybe you want to put some of these questions in your bound reference as opposed to doing them in your workbook. All right, so definitions. So again, you don't need to know these off by heart. You can always refer back to them. So a trial is a single experiment, okay, such as a single roll of a die. The sample space is the list of all possible outcomes from an experiment. Okay, so when you roll a six-sided die, the sample space is 1, 2, 3, 4, 5, 6. So they're the possible outcomes. An outcome is a possible result of an experiment. An event is the collection of favorable outcomes. And equally likely outcomes are outcomes that have the same chance of occurring. So, if we were to roll a die, it's equally likely that you get a 6 as it would be for a 2, etc., etc. Now, in probability, we always talk about, always measure it from 0 to 1. Okay, so you're never going to have a probability below 0 or above 1. So you can see on this scale here, 0 means it's impossible. All right, so think about what things have a 0 chance of happening today. So me flying to China today is impossible. Okay, it's just not going to happen. Me having another cup of tea this morning is certain. Okay, so I've got my cup of tea right here next to me. I'm certainly going to drink it. An even chance, I've got to go to the post office. Maybe I will go. Highly likely I'll go for a walk. Okay, so highly unlikely I will drive my car to a petrol station. I don't need petrol. And yeah, so things like that. I could go on for days. I could too. All right. So when we're calculating the probability, this is your basic formula. So the probability of an event is the number of favorable outcomes over the total number of outcomes. So if you were to wanting to roll a 6 on a dice, it appears once, and there's 6 numbers on the dice, so the probability of rolling a 6 is 1 over 6, or probability of rolling a 5 is 1 over 6, okay? Experimental probability is calculated in the same way as theoretical probability, but uses the result of an experiment. So in this topic, we'll look at experimental probability. So it's something that's actually happened. So maybe I flipped a coin 100 times and I've got my samples of my outcomes all listed. So that would be experimental probability. Whereas theoretical probability, I know the probability of flipping a coin and getting a head would be 0.5. Okay, but in reality, if I did it 100 times, maybe it would turn out to be 0.47. Okay, but it would be pretty close to 0.5. the long run proportion in the experimental probability for a sufficiently large number of trials, I don't know what that means, is, I missed the word is. So basically, if we were to flip a coin, say, let's say 5 times, you could possibly get 5 heads in a row. But if I was to do it 500 times, you're more likely to get the experimental probability to be close to the theoretical probability. Okay, so the more trials you do, the higher the likelihood that your experimental probability would be the same as your theoretical probability. Okay, so let's move on and do some questions. So I've just chosen a few questions from the textbook. These videos will be done in 2 parts. So I'll go over the theory and the easier questions in one video, and then the more challenging questions in a separate video for those of you who probably don't need to watch all the easy stuff. Okay, so question 3. Let's just get my pen up. Oh, sorry, you think I'd be a bit more organized? Okay, a 10-sided die numbered 1 to 10 is rolled once. Find these probabilities. So the probability of getting an 8. Okay, so there's only 1 8 and there's 10 sides. So the probability is 1 over 10. The probability it is odd. Now, if it's hard to list or hard to think about, well, how many are odd, just list them. So the odd numbers would be 1, 3, 5, 7, and 9. So in total, we've got 1, 2, 3, 4, 5. So 5 desired outcomes out of 10. So, and always simplify. I've been writing them as fractions. It's all right as a fraction or a, oops, that's not what I wanted to do. It's not 0.5. 1/10 is 0.1, but you can leave it as a fraction or you can leave it as a decimal. I think fractions is a lot easier to deal with, especially when we're doing other probability later on and you need to multiply. I find it a lot easier to multiply fractions than it is decimals, but you can put your answer as a fraction or a decimal. I'm going to leave my answers as fractions because I prefer fractions. Okay, so that means if we've got probability of odd is 0.5, then probability of even is the same. Okay, where are we? Less than 6, so if it helps, you can write all your numbers less than 6. So 1, 2, 3, 4, 5. So possible outcomes, 5 over 10, which is also a half. And I'll let you do the others. So probability of prime, remember that 1 is not a prime. So 2 is a prime number. Remember, a prime number is anything that is only divisible by itself and the number 1. Okay, so 1 is, even though it's divisible by itself, and 1, it's not considered a prime number. It's a unitary number. All right, probability of 3 or 8. Okay, so think about what that would be. Probability of 8, 9, or 10, and greater than 10. So if you've got greater than, sorry, not greater than 10, greater than 9, it's not including 9. So the only number greater than 9 on this die is the number 10. So the probability of that would be 1 over 10. Okay, so I'll leave you to do the rest of them. Let's move on. All right, question 4. An experiment involves tossing 3 coins and counting the number of heads. Here are the results, running the experiment 100 times. So this is experimental probability, what I was talking about before. So we know that the likelihood of getting a head would be 0.5 or getting a tail would be 0.5, but experimental probability will slightly differ to that because it's what's actually happened. So you might flip a coin 100 times and your friend next to you does the same thing. We're tossing 3 coins, but she might differ to you, okay? But you'd be very, very close. Okay, so experimental probability of 0 heads. So I might just write that down. So the frequency was 9, and we've done the trials 100 times. So 9 over 100, or if you wanted to write that as a decimal, it's 0.09. I think your textbook puts the answer as a decimal, but I'm happy for you to leave it as a fraction. B, 2 heads. So we've got 43 over 100 now. So as a decimal, that's 0.43. Fewer than 2 heads. So if we're fewer than 2 heads, we don't want 2 heads, we want less than 2 heads. So we just need to add the 9 and the 38. So the 9 for 0 and 38 for 1. So that gives you 47 over 100, which is as a decimal 0.47. And then lastly, D, at least 1 head. So at least 1 head means we include 1 head. So we've got everything but 0 basically. So sometimes an easier way is to subtract what you don't want. Okay, so in this case, we can say, all right, well, we did 100 minus what we don't want, so the 9 over 100. So you could add them all up if you like to. You'd get the same answer as if you were doing 100 minus 9. So 91 over 100 gives you 0.91. All right, let's move on to the next question. An experiment involves rolling 2 dice and counting the number of 6s. Here are the results. So again, we've got experimental probability. So I might just talk you through this one and see, and you can pause if you want to do it on your own. So 0 6s. So we've got 62. So we've done it 100 times. 62 over 100, or 0.62 as a decimal. 2 6s, 3 over 100, or 0.03 as a decimal. Fewer than 2 6s. So we want 35 and 62. So you add them together and divide by 100. And at least 1 6. So we want 1 or 2. So you add them together. 35 plus 3 over 100. All right. So girls, in the next video, I'll be going through these more challenging questions. Please always come back into the call if you're watching this during our lesson, and you can ask for help with anything. Okay. Bye, girls.